Gene Therapy by Jordyn. Now, what is gene therapy? Well, it's literally therapy for sick or bad genes, but the real definition is a type of biotechnology that is used to treat, prevent, or cure a disease by changing a gene that is broken. Wait, but what diseases does it cure? Well, because gene therapy has evolved so much over the years, it can cure lots of diseases, but if we had to sort these diseases into two groups, they would be genetic diseases like hemophilia and sickle cell disease. Genetic diseases are diseases that are genetic. The second group of diseases that gene therapy can cure are acquired disorders. These diseases develop after birth and include things like leukemia. Acquired disorders can be caused by things like environmental exposures. Gene therapy uses a vector to deliver the necessary genes to treat the disease. Viruses are the most common vectors that scientists use because they have the natural ability to deliver the genes to the cells. Okay, but are there techniques the scientists use? Yes, gene therapy has two techniques. The first is somatic gene therapy, which transfers a section of DNA to cells that are not used for reproduction. Now, as you may have guessed, the other type of gene therapy is only used for reproductive cells. This therapy is called germline gene therapy. Scientists use gene therapy to modify cells inside and outside of the body. When it's used to modify the inside of your body, a doctor will inject the vector directly into a patient. Now, if a doctor wants to modify cells outside of the body, well, it's a lot more complicated. The doctor will take something like blood or bone marrow and separate specific cell types in a lab. The vector with the necessary gene will then be introduced to the cells. Then those cells are injected into the patient, and then they'll perform gene therapy. Wait, but how exactly does gene therapy work? Well, this diagram shows it perfectly, but let me break it down for you. So here you can see the viral vector that I explained earlier with the functional gene inside it. The vector will go into the human cell, and the functional gene will travel through the cell into the nucleus and replace the defective gene. But how has the science gotten so advanced? When did gene therapy start? So, gene therapy's history is long and complicated, and if I explained every detail, then we would be here for hours. So, here's a brief, simplified history. The original concept of gene therapy began in the 1960s and early 1970s, but gene therapy never actually happened until 1990. The first person who successfully performed gene therapy was a guy named W. French Anderson. He was dubbed as the father of gene therapy after a team he led cured a hereditary disease in a 4-year-old girl in 1990. But he didn't really cure her because she was left unable to fight infections, so oops! European researchers in the 1990s also focused on gene therapy, but 5 out of 20 of the treated children developed cancer within the first several years because the vector set to their T cells activated oncogene, which triggered leukemia. And then, in 1999, an 18-year-old died after receiving gene therapy. Could you imagine the conversation between the scientists being like, maybe this isn't safe? So then, gene therapy came to a halt. But then, in 2010, it came back. Scientists figured out how to make better vectors that wouldn't kill people, give them cancer, or make them unable to fight disease. The new vectors don't go wherever they want in the body. Instead, they just stay on their path so they don't trigger the immune system. Now, of course, there are some impacts of gene therapy, and we're going to split them into parts because there's a lot. First, there's scientific impacts. For the scientific community, gene therapy was and is a huge deal because it shows that diseases could be cured. It's a giant leap for science and medicine because these scientists can just put these vectors into people and their diseases will be cured. I know it's not that simple, but you get the point. The second category is social impacts. Many people believe that gene therapy is dangerous because the previous situations didn't go so well. They also raise ethical questions related to tampering with human nature. I mean, if you've seen enough movies, you know that changing Mother Nature doesn't end well. But it could also lead to improvement for future generations. The third category is economical impacts. Now, I think this one is self-explanatory because gene therapy does not sound like something that would be cheap. The estimated spending for these therapies over the next 15 years is $306 billion. 1.1 million patients are estimated to be treated with gene therapy in the next 15 years. And lastly, the fourth category is political impacts. The opinions of gene therapy are already split because people have ethical questions and beliefs surrounding it. Gene therapy did not have a great start, so people don't really believe that it will do any good. It will most likely add more of a divide to the world as it continues to progress. Now, I've talked about gene therapy's past and present, but where do scientists think this could lead us in the future? The biggest goal of the scientific community with gene therapy is curing cancer. Curing cancer has been a goal of the scientific community for forever, and now because of gene therapy, it might be possible. After decades of effort put into gene therapy, the future of it is incredibly promising. New discoveries have led to several life-changing treatments for patients, and many more things are being developed. Gene therapy will become a very important staple in the medical and scientific fields and will continue to grow and develop for many more years.